Hey, hi guys. Good evening, everyone. Let me just start. So, in the last session, we had seen the error and exception handling. Today, we are going to talk about the what is artificial intelligence, what is machine learning, what is data science, and all those different things we'll look into. Just have a basic understanding of these things that we are going to learn. Okay. So, for this, before starting, I'll start with the term that you might have heard a lot of times, that is artificial intelligence. So can anyone define this particular term, artificial intelligence? So you might see there are two basic words, right? The first one is artificial and the second one is intelligence. Okay, so if and both of these words has certain meaning, right? So what does artificial means and what is intelligence means? If you combine those two things, you can directly understand the meaning of artificial intelligence. Human behavior displayed by a machine, that we can say is an even accurate. Okay, so first word is artificial, second one is intelligence. Right? Artificial means what? Something that is made by humans, something that is not natural. If something is not natural, that will be artificial, right? And intelligence means what? The ability to take decision, ability to think, ability to reason. Take decision, ability to think, right? So if something has this ability, some artificial thing has these abilities, so these are that we can say as an artificial intelligence. It could be some software, it could be some hardware, it could be some combination of both. But yeah, we can say that particular thing as an artificial intelligence. Now, artificial intelligence is a very vast variety, right? Now you can say, let's say if artificial intelligence is the whole superset, then there will be a lot of things comes. The machine learning is a subset of it. Machine learning, right? And inside machine learning itself, we have deep learning. Deep learning is a subset of machine learning, right? And yeah, so this is the hierarchy. Like if you have, let's say, artificial intelligence, the whole thing, then artificial intelligence is the superset. Then machine learning is a subset of that, and even deep learning is deep learning is again a subset of machine learning. So now we can let's just understand where does it the data science comes into play and all that. Before that, let's understand the machine learning actually. There is, very little bit different between artificial intelligence and machine learning, as it covers more area. You can say as it is a superset, but mostly tasks that this particular thing that we talked about, anything having intelligence, we can say artificial intelligence. That can be achieved by machine learning. If you make some machine learn something, then that machine can take decision. That machine can think. So we can say the process of achieving the AI is machine learning, and not only machine learning. There are some other hard-coded algorithm as well. You might have heard of heuristic search or A-star search and all this. They also come into artificial intelligence. That's a very vast topic. We're not going to touch on that. We'll be on the machine learning side basically. Okay. So now again, machine learning. What is machine learning? If you make some machine learn something, then that can be thought of as a machine learning, right? if some artificial thing, some machine, we can make it learn anything, like some patterns, some images, videos, or anything, right? Then we can think about it as a machine learning. Okay, now how do we do this, and what are the different parts of it, right? So there are basically three types of machine learning problems, right? There are three types of machine learning. And before going to that, let's understand the difference between machine learning and how do we solve the problem, okay? The first way is like the classical programming. Right? What do? We do classical programming. Let's say if I ask you to create some function, what will you do? You will create the function, you will give some input, and that function will give you some output, right? So what do? We, let's say, have, this is the classical programming, classical function, right? Now, what will happen? You will give data to the function, right? And you will tell the rule, right? What rule you are going to perform on that, right? That rule. And this will give you the output, right? This will give you the output. Okay. Now, while giving it a rule, a data and a rule, it will perform the output. For example, if I take some example of it, let's say you give the data, let's say 1, 2, and you told that you have to sum them together. The rule is sum. Then it will give you the output. What? What will be the output? Output will be 3. So the rule is plus. Output is what? Output is 3, and this is the data, right? Now think about it. It can be like anything, like let's say 3, 4, and the rule is of multiplication. Then the output will be what? Output will be 12, right? So this kind of a data, like this is a classical program, right? You know the output is fixed. Now think about is a scenario where you do not give the rule. You do not tell about the rule, right? What do? Is you give the data, and you give the output, right? Now think about this particular scenario. It will help you. If you understand this, you will be able to understand the whole machine learning, like the more than machine learning process of it, right? More than 50% of machine learning you will be able to understand if you understand this. So if you give the data and you give the output, right? And let machine itself understand, just program it in such a way. Let's program this code in such a way that whatever it will be able to try and find out the relation between the data and output, that we can say rule. For example, if you give the data 1, 4 and the output is 4, then if I ask that, what rule would have been there? Then you can, you as a human being will be able to guess that it will be multiplication, right? If output is 5, then you'll be able to guess that it will be plus, right? So this kind of a thing, if you can do by this, machine learning process, then that is called a machine learning problem, right? That is called a machine learning. Now, we do not use machine learning for which the output is already, is doable. If the problem is directly doable by classical programming, you never need to solve that by your machine learning, right? For example, if I ask you to multiply two numbers, there is literally no need to use machine learning for multiplication of two numbers, right? There is really no need to understand to create a machine learning or artificial intelligence for multiplication of two numbers. Neither if you have to do, let's say you have to do complex tasks such as integration, differentiation, or even complex than that. Let's say you want to perform some series calculation, right? Then even in that itself, you don't need to use machine learning itself. Why? Because you have a particular formula and you can just put it into that function and you can actually solve that, right? So there is absolutely no need to create a machine learning model or in artificial intelligence for which the solution, the hard-coded solution is available. Now the question arises, then for what kind of thing you will be using the machine learning, right? Now think about those things that cannot be hard-coded, right? For example, driving a car. If I ask you about driving a car, just uh, create a software that drives car. There is no hard and fast rule for driving the car. There are few six things. If you if you press the accelerator, the car will go faster. If you press the brake, it will stop. If you turn, then it will turn, and all those things are different. But in a real life scenario, in some roads like India, if somebody is driving the car, then there are no hard and fast rule how to drive a car. You have to use your presence of mind. So you must have some intelligence, right? Now, it cannot be formulated. You cannot create a formula or any mathematics to drive the car, right? Then in this scenario, you can create a machine learning model that will learn from the data, from the actual driver. So what will you do? You will actually drive the car. You will record all the scenarios. You will record by the camera, by the LiDAR sensor, by the sonar sensor, all those different things. You will record the scenario, and you will also record the action of the driver. So based on all those different things, the machine will be able to understand by getting the scenario, what the auto driver or the machine learning driver has to do, right? It will try to understand from the data available, right? Millions of billions of hours of driving, and from that it will able to understand what it has to do in that condition, right? So that is a machine learning problem, because you cannot create a formula or you cannot create a mathematics for driving a car, right? But if I ask you, if you want to calculate a series operation, then definitely there is a formula. You can just hard code it and you'll be able to get the answer. Now, so tell me some example of some other example of machine learning where we can implement machine learning. There are two types of things. The first is rule based, right? This particular scenario that I explained here, this is nothing but a rule based scenario, right? The previous scenario that we explained here, this one, right? This one is a rule based scenario, right? Here you know the rule, right? You can simply create an application for that rule, create a function for that rule, right? Now, if you cannot solve any problem by rule based, you can actually have machine learning robots or machine learning software to solve that particular problem, right? So that is now you can think about it. So yeah, robot cleaning the house, because when you are cleaning the house, there is not necessary your pets can be there on the wall, sorry, not wall, on the floor. There can be some important things lying on the floor, right? Like some your shoes might be there on the floor. There are different things. You might also, your food or some small child might be there on the floor. So it has to just understand that all those different things, there can be uncountable scenarios of the same. So you cannot code for all those scenarios, right? So for that, you can just create a simple, now that is, I would say, a machine learning solvable problem, okay? Similarly, cooking food, somebody has says image processing, that's also fine. Advertisement suggestion of product based on our searches, Amazon, Google, etc. These are the some classical example you might also find on the internet as well. Okay, so now you must have to understand what type of problem is solvable by AI and what type of problem you can solve directly without using AI or machine learning, right? So if you clearly distinguish between these problems, your half of the solution is done. Okay, now as I told you, you have to understand this particular thing. When you give the data involves both the input and output. Like when I say data means it will have both input and output, right? I'll talk about it later on.